Welcome back, everyone. Welcome back. So thanks for lunch and great conversations I had with several people. We're now moving into theme C, where we're looking at the impacts of AI and big data on productivity. Unfortunately, Corrado can't speak, so he's lost a voice, so unfortunately isn't able to be here today. But we have Danbee from the Korea Institute for Industrial Economics and Trade, and we have Professor Frederick Warzynski from Arhaus University. So we'll start first with Danbee.
Thank you for coming this session. I'm Danbee from KIET, and today I'm going to talk about my paper, AI Adoption and Firm Productivity. This paper is an empirical study that examines a firm's AI adoption actually increased the productivity in the South Korean context. Let me define the term AI used in this paper first. We follow the definition by Statistics Korea because the main variable we used for this study is the AI adoption at firm level, and that is generated by this Statistics Korea. Okay. And they define AI as the technology underpinning programs or algorithms capable of human-like learning, reasoning, perception, and understanding of natural language. So this definition is similar to that from OECD. When we look at the development and diffusion of AI, more businesses are relying on AI for their business operations. So firms are applying AI at very wide range, including managerial tasks, market or product analysis, and future projections and decision making. And AI is now considered as a new GPT, and it is expected that it may have an effect on every aspect of business operations, including international organization remaking and influencing its external competition and altering its consumer relationships. But there are limited empirical evidence on this topic. One possible reason is data limitation. There are few reliable and representative data sets on the firm AI adoption, and we can find that the very first surveys conducted by consulting firms typically covered the small number of large firms. So here's the research question of this paper. What is the effect of AI adoption on firm productivity? This topic has several challenges. First challenge is data limitation. So AI uses is actually considerably low nowadays, and also AI may have large firm bias. So for these reasons, the study using the firm level data is critical to find out the more accurate relationship between AI adoption and the productivity improvement. So to address this issue, our paper used the data set from Statistics Korea, which covers large number of firms. And the second challenge is endogeneity issue between the AI adoption and productivity improvement. We think that there may exist a reverse causality between those two, and also there exists the unobservable issue that may simultaneously effect on both of variables. So by applying the instrumental variables at firm level variable and industry level variable, we will gonna resolve this issue. And the last one is, it's hard to find what determines the relationship. So I mean that it's hard, the underlying mechanism to change the productivity, underlying mechanism for the productivity change is not that easy to find by analyzing the AI adoption and productivity. So to resolve this issue, we are going to see other moment changes within the firms in this paper. So this paper will provide an empirical evidence for the effect of AI adoption and firm productivity. To show this, we're going to use unique firm data, the firm-level AI adoption, and firm and plant-level performance data from the Statistics Korea. And we have 3 key findings in this paper. First one is, actually we could not find the significant result between those AI adoption and firm productivity. That is consistent in both of OLS estimation and the IB estimation. But we do find the productive improvement to the certain specific firms, such as multi-plant-owned firms. And they also shows that by adopting AI, they narrow the productivity gap among the plants within their own firm. So multi-plant firms means that the firms that have more than 2 plants within their entirety. So this paper contributes to AI literature with comprehensive empirical analysis employing extensive firm-level data. There are a growing number of studies on this topic. We can find that many papers try to find the accurate proxies to measure the AI adoption at firm level. But although those efforts are tried, the results, I mean that the relationship between AI adoption and firm performance is still mixed results. Some of the results shows that the productivity improvement has not shown, and that is called as modern productivity paradox. And the heterogeneity across the different firms also found. And these days, the papers on this topic started to consider the endogeneity issue to get more accurate results between the AI adoption and firm performance. Here's an outline of this presentation. Firstly, I will talk about the data set I used, and then we will move to the estimations and go to the conclusion. This data set, this paper used 2 data sets. We combined 2 data sets. One is the data set based on the firm level data. The other one is based on the plant level data. This is the first one and constructed by the firm level. And it is survey based on the wide-ranging survey of firm activities across all industries. All the Korean firms with 50 or more regular workers and roughly around 200,000 USD in capital have to answer this survey. And I will call this survey as SBA. And SBA start to survey the respondents on the adoption of new technologies, including the AI. The reference year is 2017, and they directly asked the respondents whether the firms have adopted any of the new technologies, including AI, and those responses compiled by binary variable. So this is the example of their question. One issue can be raised for this question because they did not distinguish the development and adoption in their question. So the example question is your company currently utilizing or developing the first industrial revolution technologies, and then firms can move to the next questions. So this paper will use the direct measure using the Statistics Korea survey. Let's see the indirect measures of AI adoption, which is widely used in the previous studies. Previous studies indirectly measure the use of AI using a proxy variable, such as job postings or patents related with AI skills. Using the proxies, it is difficult to confirm whether firms use AI technologies in production process. For example, the patent data may exclude the instances of adoption through the outright purchase or licensing, and the job postings also difficult to distinguish whether the demand for AI is for development or adoption or preparation. Of course, the direct measurement also have a pros and cons. And actually, before we lightly discussed the direct measure, we used also hard to distinguish the development and adoption. But we're gonna talk about this issue later on this presentation. This is the snapshot of AI adoption rate. Surprisingly low rate is seen. So based on the all industry ratio, we can see that in 2018, around 3% of adoption rate is. And this is the share of AI adoption. And this is a similar result we've seen in the morning session. So larger firms and younger firms has a high ratio. Larger firms and younger firms shows a high adoption ratio. And one interesting thing is this is the result among the Korean manufacturing firms. And the first graph shows that AI sources they use. So more than 80% of firms answer that their AI source is based on their own development. Actually, self-development includes the 100% development and also collaborations with other outsourcing firms or universities, etc. So this is the one reason why we think the recognition of adoption and development may not that critical issue in this data set. And another data set we used in here is the mining and manufacturing survey by the Statistics Korea. This is plant level data. So the final sample is defined as establishment in the manufacturing sector and their production facilities. So, and we are going to consider only manufacturing industry that has pros such as it can relieve the heterogeneity issue in the AI adoption across the industries, and also it can relieve the little bias due to the broad recognition of development and adoption, because the manufacturing industry already shows that their AI sources are mainly based on their own development. This is our main variable used. The explanatory variable is AI, and this is direct measure. That is 1 if a firm adopts AI, or otherwise it is 0. Let's see the statistics between the AI adopters and non-adopters. Generally, firms adopting AI are very superior to others in terms of performance. As you can see in this table, almost all variables have higher values at firms that have adopted AI. I think this implies that there may exist overestimation risk for the performance. So that's another reason why we have to use IV estimation to correct those issues. Before we go to the estimation results, let's see the previous studies first. The previous studies on AI adoption and firm productivity shows that the inconclusive results. So the reason for that is probably first one is the limited data set and the measurement issues to detect the AI adoption, and the other one is endogeneity issue, we think. So that's why this paper tried to solve these three issues in here. And previous studies also shows insignificant results, and to discuss those insignificant results, there's a productivity paradox concept. And about the insignificant improvement, some studies say that probably there exists a time lag between the adoption and the learning time and the full installation. Or some studies say that probably AI is not that influential technology than our expectation, compared to our expectation. So despite all the positive or negative or insignificant relationship, the current empirical evidence gives little information about the underlying mechanism for the productivity change. That's why we try to another moment within the firms to find out these mechanisms. Here's our model specification. We estimate the relationship between AI adoption and the firm productivity using this model. The dependent is labor productivity. The reason why we firstly employ the labor productivity is it is more intuitive to interpret, and I think it's less sensitive to compare to the TFP, and it's easier to compare with the previous studies that used labor productivity. And as a control, we include the firm level data and industry level characteristics and years, etc. But we still have endogeneity issues in here. So we employ the instrumental variables in here to address the endogeneity issue. The first instrument is industry level variable. Actually, this is an AI adoption rate within the same industry. The reasoning is we think that the AI adoption ratio within the same industry increases, the competition and the knowledge diffusion would increase, and that may spur the AI adoption of firm I. And at the same time, other firms' AI adoption may not directly affect on firm I's productivity. So we think the exclusion restriction is satisfied in here. And the other instrument is firm level instrument, and that is named BEAM. It is a combination of new technologies, including big data, IoT, and mobile. The reason why we choose these three is based on the previous study by Cho et al. 2022. This study shows that in the Korean manufacturing industry, there's a pre-existing technologies before adopting AI. That is big data, IoT, and mobile. So we think that those have really highly correlated, and now we have to see the exclusion restriction, and by doing the simple regression between these three three, technology adoption and productivity, we could not find any significant results. And also, as you can see in this graph, when we compare the non-adopters and adopters of AI, then we can see that the productivity movement is diverged, but the non-adopters and adopters of new technologies, not AI, they shows very similar pattern trends for their productivity movement. So we think that these three new technologies may satisfying the exclusion restriction in here. Here's the results. We can see that there's no significant result in here. The only thing we have to see in here is the IV estimation result shows the magnitude increases, and that means IV estimation corrects the overestimation risk in here. By doing the same estimation, we found that the productive improvement occur among the multi-plant owned firms. It is about 50%. And now we want to see why this improvement happened. So we're going to see the AI adoption and plant productivity gap within the firms. So before we move to the estimation, let's see the descriptive statistics between the multi-plant firms and single-plant firms. Higher levels of sales and other employment productivity and age and AI-related technologies are shown in the multi-plant firms. We estimate the relationship between the AI adoption and the productivity gap within the firm. Our dependent is named as gap, and it is the productivity difference between the plants within a firm. So when we estimate the results, then we can see that the estimation results show a narrowing of productivity, the productivity gap between the plants due to the AI adoption. So in sum, we could see that in the previous estimation, we found that the firms with multi-plants has a productivity increase from AI adoption. And at the same time, we could see that the productivity gap between the plants within those multi-plant owned firms has decreased, and we think this implies underlying mechanism why the multi-plant owned firms shows the productivity increase by adopting AI technology. Unfortunately, it's difficult to grasp the directions of productivity movement in each plant within the firm from this estimation. So here's conclusion. This paper used the large samples in South Korean context, and especially for the manufacturing industry. And we also tried to address the identification issue, and that may generate the more accurate result we expect. And from this estimation, we got the insignificant result for overall, but as for the special type of firms, we could find that the productivity improvement can be shown, and those mechanisms should be considered when the policymaker tries to make the policies or supporting aids to spur the AI adoption for their firm's performance improvement. again, we found that AI adoption may not lead the productivity gain for the firm overall, but multi-plant firms have shown the productivity improvement from the AI adoption. And they really shows that the reductions in the productivity gap among the plants within their firm. We still have some limitations and implications for the research, future research. We have no metric for the quality of technologies or for the degree to which firms are making this investment and acquisitions. So we're only able to capture the extensive margin, not the intensive margin of AI adoption. I think this is another example of cons of the direct measure of AI adoption. And the adjustment costs some firms may face in implementing AI may take longer to recoup. So performance gains probably require additional time for smaller firms to achieve. And another limitation is our study is only for manufacturing firms. So since the sectors have heterogeneous, sectors are very heterogeneous. For example, the service sector may have very different results compared to the manufacturings, but we could not find those results at the current paper. This is the end of my presentation, and if you have any comments, suggestions, and questions, let me know.
We need a microphone for you. Oh, yeah. Thank you very much, Danbee. That was excellent. So have we got any questions for Danbee?
Thank you for the presentation, very interesting. One question, from your data, are you able to tell what explains the reduction in the productivity gap within multi-plant firms? Is it due to reduction in labor? Is labor being substituted, or better monitoring, or centralized decision-making, or something else?
I think that's a very good question. We want to see what drives the reductions, and actually, we tried another regression using labor changes and wage changes, and there's no significant changes or effects from the labors. So that's another reason why we think that AI adoption actually increased the value added, not influencing on the labor demand. And we also control the number of employees, and we also check that the number of, or the increase or decrease of labor does not seen in this estimation.
Yeah.
Yeah, so I'm the next speaker, but anyway, great presentation, thanks a lot. So I'm just wondering two things. So first, you find that multi-plant firms gain from AI adoption. So I was wondering if you had an idea about the mechanism, in the sense that maybe firms can spread the resources more across plants, and that would be an explanation. And then the second thing goes back to the productivity paradox, and I think it's related to the previous question, is that if I remember your graph on the evolution of productivity, it was actually going down, which is against what you would expect. And so that's going to be my slide number 2, by the way. But yeah, I was wondering what you could say about why productivity has been declining in Korea in general. I mean, there's been a general productivity paradox, but is there something specifically Korean about that? Yeah.
Thank you for the question. For the productivity, I will answer about the productivity first. Actually, that graph is a simple average product by firm. And we could see that compared to the standard year, the average productivity of each firm decreasing for certain groups. And you may know that actually there's issues on slowing down the productivity growth. And that's, I think that's part of that. And when we spend out the years, actually that year is from 2017 to 2019, and if we spend out the years, we can see that the productivity increase continuously increase into 2015, and then the increasing speed is very slowed down. And if we see those productivity by frontier and laggards, then we can see that the slowdown is faster for the frontier at Korea and at Korea. So probably there's some mechanism, but I don't know yet. But the productivity slowdown definitely occurs in Korea, and that's why we need to see the effect of AI adoption on productivity in our case. Yes.
Any more questions from anyone? Tim?
I had a question. I noticed, when I look at the OECD statistics, I noticed when I looked at the OECD statistics on the diffusion of some of these complementary technologies impacting the usage of AI, Korea's sort of low adopters, for example, of cloud computing. And to what extent do you think that this may be contributing to some of the slowdown as well?
But what I think about the other new technologies is probably depending on the regions or the industries or countries, probably the effective new technology would differ. And that's one of the reasons why the specific new technologies shows very different adoption rate. And in Korea, the three new technologies are pre-existing technology for the AI, and that would differ for other countries. So probably as an infra technology, those differences may occur the low adoption rate for specific technology and others, I think, yes.
So I had a question. Actually, just getting at the sort of mechanism point that a few people have said, you actually have some quite rich information on how AI is used, don't you? Like in production or in sales or marketing and different things. Do you see these sort of convergence results for some particular type of AI, like to do with production? Could something like that give you more of a, if it's for one type and not for others, could that give you more of an idea of the mechanism of why we're seeing this convergence?
I think that's a good point, but I've not seen that in detail. But one thing I can say now is because this is manufacturing industry. Actually, most of AI use is focused on the productivity development and the business operation, the operating system and the process. So I have no.
Okay, Aditya, can we just get?
Just one general suggestion. I thought your paper was great, and as are a lot of the other papers that have been presented. But I think the notion of AI remains a little bit amorphous. And, I think there are great efforts to measure. But I think we need more stories and description of what is actually happening at the level of the firm. The kind of disaggregated data that Jonathan described may be a first step. But, maybe some case studies as well to motivate the empirical analysis, because at the end of it, it's not completely clear what we should expect. And whether this is a force for convergence across plants within a firm, as we heard in an earlier paper, or across firms within an industry, or ultimately even, globally, or is it a force for divergence? I think we'll have a lot to do with what is actually happening when firms adopt artificial intelligence. And I think after Avi's nice stories I feel there's a little bit of a disconnect between the story and the description on the one hand and what we are measuring on the other hand.
Mm-hmm. Thank you.
Okay, any final questions? No? Okay, so thank you very much, Danbee. We have Fred Warzynski next.
Or should I use this? Oh, I'll see. How did I switch? This the green button, right? All right, lovely. I don't know how much time you want me to speak. I have plenty of time, so I have 1 hour and 30 minutes now. So let me go to a full seminar. So let me start by thanking the organizers for this wonderful event. Very great initiative. It's lovely to interact with so many researchers from all around the world, talk about new research and about this really super hot topic. Cannot find a hotter topic right now than this. So it's my first time back in the US since COVID. And I'd forgotten about the lovely consequence of jet lag. So this is probably the worst time of the day for me to talk, but I'll do my best. My paper is very, very much related to the previous paper, and I really enjoyed the talk. So it's going to be an I/O perspective on the topic. So it's going to be very much related as well to the measurement issues, measurement of AI, and also measurement of productivity, and eventually the relationship between the two. Right? So this study has been conducted in very, very close cooperation with Statistics Denmark. So we are extremely lucky in Denmark, and I think we had some discussions yesterday, to have this wonderful relationship with our statistical office. And it's really involves regular meetings and fantastic support in terms of explaining what the data means, how the surveys are conducted, how to match the data. So, and also access is very much easier than in other countries like the US or Korea. We can have remote access on our desktop computers in the office. So it's, and Statistics Denmark also has a great history to collect data in a very precise manner. So there's this culture in Denmark of close cooperation and trust, right? So firms actually do not really fear to provide information about these surveys, and it's also required by law to answer. So the answer rates that we get, the response rates that we get from these surveys is typically like 98, 99%, which is unheard of in other countries. So my talk is going to be very complementary to the previous one and to other of the other papers, in particular Flavio. So I'm also contributing to the AI diffuse thing. Although I'm going to go into more details, as I said, about the measurement issues. It's very much work in progress. There's no paper yet, but it's coming, and I'll explain you why that's been the case. All right, that was my long introduction. So let me start with the big picture, and I think the previous paper was already giving you an idea about that. So there's this general belief that AI, machine learning, is going to generate huge productivity gains, right, in the economy through various factors. And that's because, as has been stressed many, many times, it's a general purpose technology, so it's a platform that allows other innovations to spread, and therefore it has this snowball effect, right? But then we observe, as we've seen in Korea and as we've seen in most advanced economies, this so-called productivity slowdown. So productivity growth has been going down for 2 decades now, despite the fact that there's been a huge increase in investment in new technologies. So that's been referred to as the new productivity paradox, following Solo's old term that you can see computers everywhere but in the statistics. And that has led to some people to try to understand why that is the case, right? Why is there this mismatch between what we expect from the technology and what we see in the data? So by the way, this big picture story is based on this paper by Brynjolfsson, Rock, and Syverson, NBR working paper a few years ago already, thing that's been published since. And so the main reason that they stress in that paper is, first of all, that maybe there was false hopes. Maybe we were expecting too much of that technology and it didn't deliver, right? That's been very easily discarded by many, especially the authors. Maybe it's too early to see the effects, and I think that came also in the discussion this morning, in the keynote. Maybe it takes some time for firms to learn how to use AI in an efficient way. And there are some implementation lags in AI to actually deliver results. And the last issue is mismeasurement. Maybe we cannot really measure properly AI implementation. And that goes back to some of the discussions we had about the previous paper as well. So, this paper is really going to be about implementation lags and using panel data in order to deal with it, and also about the mismeasurement issue, about trying to come with some preliminary measurement of AI, even though it's not perfect. So the next question is, how do we actually measure AI? And it's going to be quite straightforward. It's hard, as we said. I mean, statistical offices around the world are trying to capture these concepts in a better and more precise way over years. So we're going to start somewhere, and we're going to start with a very simple measure, like Flavio and the previous paper. It's like yes or no. But then we're going to try to dig more deeper into what it means, and eventually go into more details. So once we're going to have this crude measure, we're going to see what can we relate AI to, and in particular productivity, and also workforce composition. And I'm going to explain exactly how we can do that in the Danish context, and explain in details the data, since I have so much time. All right. So main contribution of this paper, or this presentation, or this research project, let's call it that way. So we're going to use 5 ways of ICT use survey. It's a survey that is run in every single European country for at least 25 years. And I'm going to focus on Denmark and to identify which firms are adopting AI in Denmark. So that's a question that's been asked since 2017. I'm going to merge this information with standard data sets that people have used a lot in Denmark, in particular standard accounting data, in order to estimate a production function or to come with a measure of value added per employee. And also a linked employee data set that's going to help us to measure workforce composition. So this is going to be the idea of data building, and I'm going to tell you more about that in a few slides. And then I'm going to document an extremely rapid diffusion of AI in Danish economy, an explosion in 4 years. I'm going to document as well a strong selection effect that's been stressed in several times previously. So more productive, larger firms are more likely to adopt AI, and therefore there is this correlation between productivity and AI adoption. But this is purely correlation. We would like to see if there's a causality, that actually AI leads to an increase in productivity. So I'm going to show you also that there's evidence of dramatic change in workforce composition, because we can very precisely measure what type of workers are being employed in firms. And we're going to show that firms that adopt AI are also more likely to hire high-tech workers, or techies, as has been referred to in the literature. That's probably not surprising, because if you get AI, you need people who can use it. And I'm going to show that there's actually quite some complementarity between the use of high-skilled labor and the adoption of AI. All right? And then I'm going to show you also that in the short run, and it's very preliminary finding, and that's something I was hoping to get better results before here, but I haven't managed yet, some evidence that there's an improvement in productivity in the short run for firms adopting AI. So it's not only a correlation, it's a very simple diff and diff analysis that I'm trying to improve, but I'll tell you more about that. All right? So that's it, in case I don't make it in time, although I have doubts. All right, how do we measure AI? So, and I'm sorry, the screens are pretty tiny, but I hope you can read this. So every year, as I said, since 1999, Denmark Statistics surveys firms about the use of ICT tools. And at the beginning, it was very simple. They were asking questions like we used in the 1990s. What's the share of your workforce having access to a computer? Do you have the internet? What's the share of firms of employees having access in your firm to the internet, right? And so that was a measure of AI, of ICT, IT that people were using in 1990s, like Brent Jobson and others, Van Reenen and so on. So this survey is done in close cooperation with Eurostat. Well, it's actually every member state in Europe is supposed to submit the survey, but then every member state also has the right to add additional questions. And there's also a population that they have to target, but they can also decide to increase that population if they want to. In particular, Denmark being a very small open economy, it's 5.5 million people, by the way, so there are not so many firms, so they decided to actually lower the threshold to which firms were required to answer that question. So it's all firms with at least 20 employees, so which is a little bit better than in other countries. So it's altogether around 5,000 firms that constitute something like 80% of the Danish GDP. So as I said, questions evolve over time, and so introduction of robots, introduction of ERP, how much do you use ICT in order to coordinate production. So it's basically a race against the clock. So statistical office is trying to adapt to the new developments of technologies and trying to improve the measurement. And so in 2017, they were simply asked 2 questions about the use of AI and the development of AI. So you ask, are you using AI? This is in Danish, by the way, but I can translate. And so the reason why I put that is that before the firms have to answer the question, they are explained precisely what AI means. AI or machine learning involves the use of computer software that provides access to data thinking, analysis, problem solving, and it could involve image, sound, or text analysis. And so it's basically giving a little introduction to firms about the way they are supposed to answer and to consider AI. And so they simply have to say yes or no. All right. So using simply this data set, and we have, so the question was asked every year since 2017, except in 2020, because it was decided at Eurostat level and also at Statistics Denmark that they didn't want to bother firms too much. They didn't want to have this administrative burden of having to answer same questions over again and limit the number of questions. So they decided to ask this question biannually instead of every year from 2019 onwards. But we can see that there's this huge increase in AI adoption from 6.62% of the sampled firms in 2017 to more than a third of the firms sampled in 2021. So huge explosion of AI adoption. It's also concentrated, as has been shown previously, in a few sectors, and in particular in the high-tech service sectors like ICTs, information service activities, computer programming, firms that actually produce AI and also use AI, produce AI, and sell AI to others. But also widespread in wholesale, retail, legal and accounting activities, engineering and architecture, and a little bit in manufacturing as well, but not as much as in services. And so the 2 sectors when you see a lot of AI being adopted is computer, electrical, and optical equipment, not surprisingly maybe, and machinery. And machinery is one of the biggest manufacturing industry in Denmark. Okay, these are the figures, industry by industry. So the first line, you see the percentage of firms sampled in the industry that adopt AI. And the second line for each industry is showing you the number of firms that are sampled. So I only took industries that are large enough because of confidentiality issues, and also those that were the most representative in terms of AI use. And so you see, as I said, so information and service activities is by far the largest, also from the beginning, but also to the end. But you can see this huge evolution from 28% to 75%. And here a lot of people are asking questions, whoa, especially when you look at the switch from 19 to 2021, and that's something we discussed with Flavio as well, is that there is this little bit of a change in the definition of AI use. Well, it's not that little bit, but I'll tell you more about that later. Publishing activities involve software, and video games in particular. So this is also an industry that uses quite a lot, computer programming, etc., etc. But you can see this impressive increase in every single industry, moving, and this really big jump from 19 to 21. And a lot of people will have doubts about that, but I'll come back to that. Yeah, it's too big to be true, you might think, but I'll try to convince you. This is just what the data says. You know, that's what in the survey. I didn't mess it up. I hope not. Okay. Now, let me tell you. So we have this ICT use survey. And then, of course, if you want to address the issue of productivity and labor force composition, you need to find information about that. That's not in the survey itself. So I'm going to merge these 5 waves of ICT survey with standard accounting data and the linked employee data sets. So I always use this joke when I'm presenting and using Danish data. Using Danish data is like playing with Legos. You have a lot of little bricks all around, and you put them together in order to build your story. And so we have this unique firm identifier that we can use, and you have tons of surveys. Here and then we can match all these things together. Of course, it's Denmark, it's a small open economy, but it's a fantastic laboratory in order to analyze all these kind of questions. So the linked employee data set, the Danish linked employee data set, is pretty well known in economics. It covers the entire population of Denmark, and in particular, those that are employed. And for those that are employed, and that's starting in 1980, so we have this really huge panel over almost 50 years now. And that contains information about the occupational codes of every worker, the education, the age, the gender, where the person lives, and of course it's connected to the plant and to the firm where that person works. So we're going to use that data in order to identify high-skilled workers. And so there are 2 ways we can identify high-skilled workers. At least there are 2 ways I'm going to try to define it. The first one is very straightforward, is to use this category called techies workers, which in the ISCO classification, which is the ILO standardly used classification, is code 25. It's called the techies. And so if I go back again, it's in Danish, but it's basically work within the information and communication technology. And so that involves software development, web and multimedia development, system administration, design and administration of databases, and so on. So all these, and so this is also the way that many people have defined techies. Another definition, which is less, this is only very limitative in terms of high skill, right? It's only skill related to ICT, but you could also have engineers, for example, or people with different education or different job definition to be involved, to be considered high skilled. So we also have an alternative definition of tech workers that is a little bit more, more inclusive. And so I'll tell you more about that. And then there's the accounting data, which is pretty standard. It covers the population of firms in the economy, and it's what is used to compute GDP. So it's aggregating at the firm level to the macro level. And so I'm going to use mostly things you need for the estimation of production function, which is one of my specialized area, to get value-added capital and employment mostly. So turnover, operating revenue, and material use as well. So we can compute labor productivity as previously used, but also estimate the production function, and TFP. All right, let's talk about that. So stylized fact, once we match this ICT use survey and the linked employee data set, we find that the number and share of tech workers in AI adopting firms increases dramatically. Also before we observe adoption. By the way, I didn't say that before, but the first time they asked the question was in 2017, right? And they simply asked firms, do you use it or not? So firms might have had adopted AI before 2017, but we don't know that. So we see that before we observe adoption, you can see already an increase in the number of tech workers and especially in the ICT industry. It increases from 57 to 63% in just 2 years' time. And in other sectors, we don't see that huge increase. So you see this really concentration of hiring of tech workers. Now, if you match with the accounting data, you also find that AI firms have an average 9.4 higher labor productivity than non-adopters. So quite a large. This coefficient is you can run that regression. It's very simple premium regression, as we call it. You can run that regression year by year, and you see that this coefficient is much larger for early adopters than for later adopters, which suggests, again, a really large selection effect. So this suggests, as has been stressed, huge selection of firms into AI, more productive firms adopting AI. But can we say something about changes, right? So that's going to be the next step. So I'm going to run a very simple diff and diff regression and also estimate the production function using AI as one of the variables in the production function. All right. So that's the coefficient for the adoption premia. So as you can see, so firms adopting AI have much larger value added, have much larger employment, so they're larger, and they have also a larger value added per employee, 9.4%, and they also have a much larger tech share, 11% larger tech share than firms not adopting AI. Right. No, this is the correlation that I stressed in the previous slides. Now let's talk a little bit more about dynamics. So I'm going to run two very simple regressions and trying to refine them. It's taking more time than expected. It's going to be forward-looking. So we're going to look at these early AI adopters, as we call them, so firms that declare to having adopted AI in 2017. And we're going to look at the change in these firm attributes. And firm attributes is going to be value added per worker and the share of tech workers. And it's going to be on the right-hand side. As you can see, it's a change. So it means it gets rid of the fixed effect and all the firm-specific components. And then it's going to be mostly controlling for industry and looking at AI adoption as a main right-hand side variable. And then the second specification is going to be running a production function, very standard in industrial economics, when it's going to be a value-added specification. I'm working on the gross output version now. When we have, in that case, 4 variables on the right-hand side, capital, capital, and then 2 types of labor, tech workers and non-tech workers. And then AI is going to be a dummy variable, and it's going to be interacted as well with the other variables. Okay, this is relatively standard as well. Of course, as has been stressed, there's a huge endogeneity issue here. Just going to try to talk about it, but I haven't addressed it yet properly. Sorry about it. All right, so that's the first regression, is the forward-looking growth rates between 2017 and 2019. And you can see that controlling for industry and the change, the growth rate of value added per worker for firms adopting AI in 2017 compared to those that don't adopt AI is 3.7% higher. And for the log of tech workers, it's actually 7.1% higher. All right, so they hire more tech workers and they become more productive in terms of value added per worker. Now you can see that there's only one star. So usually we want more stars. So which says that it's preliminary and not very, very strong, but it's still significant at the 10% level. Yeah, so you have to start somewhere, right? Yeah, and then the next specification is production function estimation. So you can see these two columns. The first one is when we pool across all industries. And as an I/O economist, you usually hate to do that because you think that the coefficient of production functions are industry specific. So you don't want to say that the coefficient of labor is the same in rubber industry than in food. But anyway, we start somewhere. And you can see that, the coefficient of labors are around 0.7 when we sum up, 0.16 for tech workers, 0.5 for non-tech workers. The coefficient of capital is around 0.3. So these are coefficients that you find typically. It's around showing some kind of constant returns to scale. And then you can see that AI in itself is actually, if you look at the first column, AI and the interaction with all the other variables are not significant, right? But then if you look at the second column, that's only for Industry 62, and I told you that's the industry where you see a lot of AI adoption. Then first of all, you can see that the coefficient of tech workers is higher than for all industries, not surprisingly. You also see that the coefficient of AI in itself is not significant, but the interaction between tech workers and AI is highly significant. Well, it's significant. There are 2 stars this time. Which shows that, well, basically, AI is complementary to tech workers. So it makes tech workers more productive. Okay, and it's not too much a case for the other factors of production. Okay, so 2 limitations. First of all, this is only using 3 years of the data. Now I have 2 more years, so I can improve that. And then it's OLS, so it doesn't deal yet with the endogeneity problem. So the problem in adopting more sophisticated production function estimation techniques, such as Oli and Pekes or Ackerberg, Caves and Fraser, and other of these new technologies, is that the number of observations is quite low, and you need lagged variables as instruments and so on to adopt these techniques. So it actually reduces the sample size to an extent that the coefficient do not turn out to be any significant. Yeah, that's maybe too technical. Sorry about that. All right. No. Okay. So as I said, the question was, do you use AI or not? But as came out from the previous presentation, and I think from Flavio's presentation as well, is that in the latest wave that I have access to, in terms of microdata, the 2021 wave, Statistics Denmark and Eurostat countries ask more questions about AI. In particular, they ask what kind of technologies is used, for which purposes, and they ask a subjective question to firms about what do you think was the impact of AI on your company. All right, so it's kind of complementary to the empirical analysis that we're running, right? So, and then also, how was AI acquired using the company's resources, of buying it from somewhere else, or some kind of combination of the two. All right, so what do you find out about that? Well, the most common AI technologies that are used by Danish firms are technologies automating different workforce or assisting in decision-making, in particular, artificial intelligence-based software robotic process automation. And so out of the firms that decided to adopt AI, 71% of them reported to have adopted this type of technology. Machine learning for data analysis was 37% in general. But if you look at differences between Between industries, it was actually 61% in ICT industries. And then technologies performing analysis of written language, that was 34% on average, but 82% in business services. Now, what is AI used for? Well, it's mostly the most common use of AI is for the management of enterprises. And that includes data analysis, ICT security, organization of business administration processes, and then later marketing or sales. And that's especially in ICT and trade and transportation. And production processes is one of the last ones because, again, not many firms using AI in manufacturing compared to services. But in manufacturing, of those firms reporting using AI, 28% of them were using it for production processes. Yeah. All right. Then, why does the use of AI? And so it's mostly to streamline workflows, to improve the enterprise product and services, and also it also generated greater earnings and actually or reduction of costs. So it means that 41% of the firms reported that AI was profitable, right? Which is kind of high compared to the figure we got this morning. That was 10%. So that's much larger here. But that's okay, and that's the final point that I want, there are two more points I want to stress. So how did you acquire the artificial intelligence software or system that you use? So it's mostly purchasing through what we call the providers, so the disseminators. So half of them, more than half of the firms adopting AI said they bought it. They could be bought but modified. They could also use external providers to contract to develop and modify them. They could also be developed by their own employees, and that's especially true in ICT sectors, as I said. These firms are the disseminators, and so 60% of firms in ICT sectors say they were developing it within their own ranks, and that's why they need skilled workers as well. And then open source software is also used quite commonly. And by the way, these categories are not mutually exclusive. Firms can use different methods to adopt or modify AI. Okay, and last thing in terms of what came out of this 2021 survey, it was the first survey that was run after COVID. And so firms were asked, did you actually implement more investment in advanced technology or digitization as a result of COVID-19, and that includes AI, but not only AI. It can also be other type of IT solutions. And 20% of the firms said yes, and that's probably not surprising based on what we've earned and what we know as educators with the use of Zoom and other technologies. Right. All right, so complementarity with the recent contributions and how it actually fits with the previous papers that we're presenting as well. So there was, as I said, the starting point was this theoretical expectations that came from AI adoption without proper measurement. And that included some case studies. That includes a paper by Brenchloff, Sunrock, and Syverson. That was a starting point of that research project, to be clear. And then there's recent empirical evidence. There's two papers with Korean data. So the one that was presented at NBR Summer Institute a couple of years ago. No, it was not Summer Institute. It was another NBR conference that was looking at AI adoption. The one that was presenting just before, that was looking at productivity in AI. The work by Flavio and co-authors and the OECD about AI diffuse and the cross-country analysis. And also there was this paper that was published as an NBR research paper, NBR working paper last week or 2 weeks ago by Esfeld, Schubert, and Zhang that is trying to look at how AI exposure is actually leading to increase in firms, abnormal firm value, if I remember well. It's more like a finance paper, but and they found some evidence of a small effect. And that's over a very short period of time. It's looking at the adoption of ChatGPT on firm value. So it's a very, very short window. But it's quite interesting. So I just read it in the plane, to be honest. But all right. So as I said, work in progress, preliminary results. I was running regression yesterday before coming. Didn't have time to show them. Better use of the panel dimension. I think it's doing the best it can now, but we have every year we get better data since we have one more wave. So hopefully we can improve that. Deal properly with the endogeneity of the production function estimation, and that's also something that can involve several dimensions. So I showed you the results with this multiplicative effect of AI dummy with the other factor, the production factor of productions. But you could also think about putting AI in law of motion of productivity, which is something that has been done for other technologies in the past, like R&D. So that would be another way to go. That's something I'm considering as well. Something that Flavio mentioned as well, and that's we're discussing for a follow-up project, and also that was stressed in the Korean data. There's this sequential process of adoption of technologies, started from computer to ERP to cloud computing, big data, and AI and robots. Yeah. And I think I'll stop there. Just two complementary, two follow-up projects as well, which is looking at how COVID as well has contributed to change in workforce composition, in particular to the fact that it led to additional investment in new technologies. So COVID being like a trigger of change in workforce composition, or structural change as it's been described as well. And then relationship with international trade decisions, such as offshoring. Yeah, all right, I think I'll stop here. I haven't been timing myself as well. But
Thank you very much, Fred. That was excellent. So we have some time for questions. Yeah, Avi?
Hi, really interesting. Thanks. So just looking at the data and the analysis you did, you presented the OLS results because you said you didn't have enough data to do the others and still get significance. My preference, I don't know if this is a universal preference, but I think it's moving this way in economics, is to show the unbiased results. And if you don't have significance, that's fine. We at least know what the distribution looks like. You're going to give us standard errors. The AER doesn't even show stars anymore for your regressions. So, because OLS has so many biases in terms of thinking about it as a productivity production function that who knows how to interpret it.
So. Totally fair, totally fair. Actually, I have some results. Nothing is significant because I don't have enough observations, but I didn't want to show it. And I'm working on it because every extra wave of data that I get, I have more observations, and eventually I will get there. But so far, I don't have anything. Well, if you look at the first difference estimation with value added per worker, that's actually, I think it's relatively unbiased in terms of, I mean, it's a different diff that is worth what it is, but it can be improved as well. But I think that's circumvents a little bit of the endogeneity. But for the production function estimation, I totally agree with you. It's part of my research agenda. I've been spending most of my time working on that. So yeah, I feel a bit ashamed to present that, but but thanks for stressing that. It's totally fair. Yeah.
Any more questions? Tim?
Yeah, you mentioned a possible COVID effect in the adoption of AI in your data, where we saw that jump. What do you think the mechanism for that is? Why do you think that there was a jump in the adoption of AI? Was it a demand-side shock or a supply-side shock?
All right. So, yeah. I think it's mostly supply. Yeah, and so it's basically firms sending their employees home and trying to have a better way of, a better way to coordinate their actions, right? And I think that's what everybody has been doing. And at the same time, realizing that by doing that, they can actually possibly work better and improve some other dimensions of their operations as well. Yeah, that's something. Yeah, I still need to dig more into. But that's probably the way I'm thinking of it. And that's also talking with companies and yeah.
Anyone else?
Yeah, just one more point. There's also a policy dimension here. So this work is conducted with Statistics Denmark, but also we've been talking with the Ministry of Employment in Denmark and the Ministry of Business Affairs. And so we are collaborating with them as well, and they are designing policies to help promoting AI and robots adoption in Denmark. And we are trying to evaluate their policies as well. So we're working together with them. And so these results are also useful in that dimension, even though, as we said, it's very preliminary. So we have to do a better job, right? That's it.
Super. Well, thanks, Fred. We'll give him a round of applause again. Thank you.